Okay, chapter 6, here we are on day 4. What we're going to look at today is how do we solve for other parts of this z-score formula. So the z-score formula is made up of a z-score, some number, the mean, and standard deviation. If we know any 3 out of those 4 parts, we can solve for the other parts of the formula. So let me just kind of show you through an example. So for example, the amount of cereal in a box is normally distributed. So at a manufacturing facility, they have machines that fill the cereal or fill the boxes with cereal. The box claims to have 16 ounces. So if you look at a cereal box, on the side it might say 16 ounces. If the filling machine is set at normal model 16.5 ounces, standard deviation of 0.3 ounces, what percent of cereal boxes will be underweight? So contrary to belief, you can't set the machine to have an average of 16 ounces in it, because that would mean that half of your boxes will go out under what it says on the package. So they actually set the machine a little bit higher at like 16.5. Let me show you a picture. So they set the machine a little bit higher at 16.5, such that only a smaller percentage now go out under the claimed weight of 16 ounces. So that's what we're looking for. All right, so you draw a picture. We know the average setting is 16.5, and we don't want to send out boxes that are under 16. So what is the z-score and what is this percentage? So z equals 16 is the number in question minus the mean divided by the standard deviation of 0.3. And so this is what we've been doing, but I want to show you where does it go from here. The z-score for this, I already did the math, is negative 1.67. And if I look at negative 1.67 z-score, this tail then is 0.0475 when I look that up in the chart. So 4.75%. So if they set the machine at 16.5 ounces, they'll send out about 4.75% of the boxes they send out will still be underweight. Almost 5% of their product will have cereal in it less than what they claim on the box. Be underweight, under the 16 ounces claim. So maybe we need to be more accurate in the amount of cereal that is placed in here. So what standard deviation is needed to keep the percent of underweight boxes at 1%? So in other words, I'm still going to keep the same average setting, but I need it to have less amount of deviation in it. And I want only 1% of the boxes to go out underweight. So I'm restricted to be 1%. So I go back to what we did last class. I only want this to be 0.01. So I need a z-score for 0.01. And when I looked that up, negative 2.33 is my z-score. So negative 2.33 is my z-score. Now, what standard deviation? So that's what I don't know. That's down here. I'm still using 16 as my value for underweight. And I'm still using 16.5 as the mean of that machine that I'm making, or that I'm using. So I multiply both sides by sigma, divide both sides by negative 2.33, and my standard deviation is 0.2146. So my old standard deviation was 0.3, my new standard deviation is 0.2146. So it has less amount of deviation, all right? comment on the new setup of this machine in terms of the lower standard deviation. Well, if this machine has a lower amount of standard deviation, what that would mean for me then, it is more consistent. Oops. More consistent. All right? Less deviation, more around 16.5. But here's the problem. The new machine's too expensive. Okay? New machine is way too expensive. So we're going to have to reset the mean so that way we send out less product underweight. I'm willing to live with 2% underweight. I don't want 4.5 to 5%. So the new machine's too expensive. What should we set the new machine, the mean, I'm sorry, of the old machine at to keep the percent underweight boxes at 2%? So we're still going to work with the old machine. We're just going to dial it up a little bit, set the new machine's mean a little bit higher so we send out less boxes underweight. So we want 2%. We're willing to allow 2% of boxes to be underweight. So what z-score is 2%? Well, that's negative 2.05. So negative 2.05 is our z-score. We still use 16 as our mark for underweight, but now we want to know what is the new setting at? What's the new mean at? And of the original machine that had a standard deviation of 0.3. So I multiply by 0.3, subtract 16, multiply by negative 1, and the new mean has to be 16.615. That's the new setting. So if I set the machine now at a mean of 16.615, whatever, I will send out only 2% of my boxes will end up underweight, and I'm willing to live with that as a manufacturer and not get yelled at by some sort of consumer reports about my product. But so this is, what can we use this z-score formula for? Well, we can use it to find a percent. We can use it to find a new mean, a new standard deviation. We could use it to find a certain value. Maybe we can't change the machine, and so we're going to have to maybe change the value on the product listing if we are going to do it that way. So, but this is just a little bit on what else can you do, what else can you calculate, and how does that work.